interesting. All right, so if we're talking about circumference, what are the two formulas we'd be using? Circumference equals?
C equals pi times r.
Pi times d, or?
C equals 2 pi r.
2 pi r. What does the letter d represent? Diameter. It's on the board. That's okay. What does r represent? Radius. So when do we use pi times d?
When you're trying to find the diameter.
When we're either trying to find the diameter or we're given the diameter. We use 2 pi r when we're finding the radius or we are given the radius. Okay? So in number 1, it says find the indicated measure. The radius of a circle with a circumference of 42 meters pi. So really the same thing as 42 pi. All right, so when we do this, which of the formulas are we going to use? 2 pi r, because it has the radius. What is 42 meters pi, or 42 pi, we can call it. We'll just call it 42 pi. What does 42 pi represent? The circumference. So the circumference. So we're going to plug in 42 pi for the circumference. We leave the rest alone. Equals 2 pi r. Now we need to solve for the radius. What is 2 pi doing to the radius? It's multiplying, so what's the opposite of multiplying? Dividing, so divide by 2 pi. Divide by 2 pi. So what happens to the pi's? They cancel. And then 42 divided by 2, which is 21. So technically the answer is 21 meters. Number 2, the circumference of a circle with a radius of 27 feet. So which formula are we going to use here? 2 pi r. We have the number 27 feet. What does 27 feet represent? The radius. So the radius. So we keep c equals 2 pi, and then we're going to plug in 27 for the radius. All right, so when we go to plug this into our calculator, you could do 2 times 3.14 times 27, or you could do the shortcut. What is 2 pi equivalent to? 6.28. So 6.28 times 27, we're rounding to the nearest hundredth.
169.56.
Get out of my room. I'm not kidding. Go sit on the bench outside. Actually, go sit in Miss Hatt's room. Miss Hatt's room. Circumference of a circle with a diameter of 15 inches. Which circumference formula are we going to use? Pi times d. All right, so 15, what are we going to plug 15 in for? The diameter. So circumference equals pi times 15. So pause. If your book says leave it in exact terms, which here it doesn't, but your book will say exact. Exact means leave it in terms of pi. So pi times 15 would be equivalent to 15 pi. So if it says leave it exact, you would leave it like this and you would move on. No typing it in. Yep. This one doesn't, so we are going to finish the problem, but it will say exact in the book. Okay? So 15 pi, which is 15 times 3.14. 47.1 inches. All right, last, find the diameter of a circle with the circumference of 39 centimeters. So we use the same formula, pi times d, because we're looking for the diameter. All right, and then where are we going to plug in 39? For the circumference, c. So 39 equals pi times the diameter. How do we finish solving for the diameter?
Divide by pi.
Divide by pi. So what's 39 divided by pi? I believe it's 12 something. 42 centimeters. All right, we're going to do 2 of the bottom. My numbers are not the same as your numbers. It's okay. We're going to do the left and the right. So today we are not, you don't have to cross it out, but we're not doing this problem. Okay, we're going to do 6, and then we're going to do number 8 on my screen. So that's 5 and 7 on yours. So it says find the arc length. So if you remember, we had 2 fractions equal to each other. What was in the top of the first fraction? Arc length. And then on the bottom, circumference. Good. So I would write this down. And then our second fraction, what went on the top? The arc measure over 360. So a piece of the circumference over the entire circumference. A piece of the 360 over the 360. Do we know the arc length of AB? No, we're finding it. So we don't know it. So I'm going to plug in an X for what we don't know. We don't know the circumference, but do we have enough information to find it? Yes, we do. You have 2 formulas to help you find the circumference, either pi times d or 2 pi r. Which one will we use? 2 pi r. And what's the radius in this picture? 6 centimeters. So circumference equals 2 pi times 6. So you'll type in your calculator, 6.28 times 6. You get 37.68. This goes on the bottom of the fraction as our circumference. All right, and then what's the measure of our arc? 60. If you have one fraction set equal to another, what can we do to solve? Cross multiply. What's x times 360? 360x. 37.68 times 60. Did I get it right? 2,268.8. Okay. All right, last step. Divide by 360. And what does our arc length equal? 6.28, and then centimeters. Perfect. Yes, sir. Yes.
Is that 2 pi 6?
2 pi r and then 2 pi times 6. Yes, sir. All right, so we're skipping the middle problem. We're going to go to the right. We use the same formula. Arc length over the circumference equals the measure of the arc in degrees out of 360. All right, so do we know the arc length? No, we're still finding it in this section. So x over the circumference. We don't know it, but we can know it. Are we given the radius or the diameter? The diameter. So we're going to use pi times d. So circumference equals pi times 28. We will round to the nearest hundredth like normal. So what is 3.14 times 28?
How do you know it's a radius or diameter?
The radius only goes halfway across. The diameter goes all the way through. So 28 goes from the edge of the circle to the edge of the circle, whereas this one only went from the edge to the center. All right, so what's 3.14 times 28? Sorry. 87.92. We put that on the bottom of our fraction. What is the measure of our arc that was given? 30. Out out of 360. Cross multiply x times 360 is still 360x. 87.92 times 30.
2,637.6.
You're both wonderful. Thank you. All right, and then divide by 360. 7.33, and then it would be in, what is it, feet. Good. We got two more things. Flip to the next page. Going from degrees to radians and radians to degrees. These are both types of angles, if you remember. So I heard Mr. Cosin, I don't know what Miss Westcott does because I can't hear her from my door. Mr. Cosin just started trigonometry, so you're going to be seeing some radians in a bit. So whenever we answer in radians, what will always be in our answer? Pi will be in our answer. So if we're going from 60 degrees to radians, we're going to multiply by a fraction. You can memorize it if you want, but you don't have to. Look at the second problem. You have 5 pi over 4. So where do we want pi to end up in our answer? In the top. So guess where we're going to put pi in our fraction? The top. And then what would go on the bottom? 180. So because we want pi in our answer, we're going to put pi in the numerator. Put 60 over 1. Then we're going to multiply. Before we do, is there anything we can cross-cancel? 60 and 180. What are they both divisible by? 60. How many times does 60 go into 60? Once. And how many times does 60 go into 180? 3 times. So 1 times pi, we call that pi. We don't call it 1 pi, just pi. And then 1 times 3 is 3. If you're in Algebra 2, you're about to find out you have to memorize that 60 degrees is equivalent to pi over 3. Like, you won't use this anymore. Number 12, we're going to degrees. So we're going to take 5 pi over 4. Do we want pi in the answer? No, because we want to go to degrees. So no pi. So in order to cancel out the pi that we already have, where would our pi have to be in our second fraction? In the denominator, which makes 180 in the numerator. Cross cancel the pi's, they're gone. What else can we cross cancel? 4 and 180, what are they both divisible by? 4. 4 goes into 4 once. 4 goes into 180 45 times. You're on a roll today, Ian. Multiply straight across. 5 times 45 is 225. And that is where we will end today.